Friends, in today's lesson, we are going to look at the following question. The main purpose of our lesson is to help on how to convert from binomial series to power series. With that being said, I would want to ask all our viewers to subscribe to our channel so that you help make it be reachable to a lot of people. Thank you for hitting that bell icon. With that being said, let's dive in. We have a binomial series of n plus k choose k multiplying with x to the power n. Now, with that being said, we're going to leave it there for a minute and come and focus on this individual here. This form which I'll write, it is the fundamental form for the binomial series. So for this boy, what we are going to do, this is k, this is k, this is k. Don't let it deceive you. So we have k choose n. So k is our power. So this is from a form of 1 plus x to the power what? To the power k. So k is our power. Choose n, x to the power what? To the power this n. So the binomial series says it is k open bracket multiplied by k minus 1, then k minus what? K minus 2. Then this will be, so this pattern, it all follows this same guy, which is k minus n plus 1. This is what we have. So this what we have, let's just come and write it here. So it is k less 1 multiplied by k less 2 multiplied by k less n plus 1. So this is all over what? This will be all over. What is our x? We have x to the power n. So this will be x to the power n divided by what? N factorial. So this what we have here. It is the general form for this. So we are going to use the same expansion for that. So we have seen that this is our k, isn't it? Observing what we have there, what is our k? Our k is n plus k. So let's just come and write it here where there is k. So this will be n plus k, open bracket. So this will be n plus k minus 1. We open another bracket. This will be n plus k less 2. This we are just going to write it the way it is. So it will be n plus what? So this will be, where there is k, it will be n plus k less n plus 1. So this is all going to be to the power what? To the power x to the power n. Now, we have seen that when x is powered to the power of n, we have n factorial. So we are going to have an n factorial. But to our question, surprise, to our question, we have k. n plus k choose k. So this also must be a factorial. But how? It's going to multiply the factorial in the general formula. So this is going to be n factorial multiplied by k factorial. Now there is something wonderful here. We have something wonderful. We are going to observe what we have found. This is n plus k. This is n plus k minus 1. So this is n plus k minus 2. So let me go ahead and just put small, tiny little brackets inside. So we had n plus k at the first. The second term, which is multiplying this, we have n plus k minus 1. This n plus k minus 2. There's one thing which I really want just to show you. If I say 3 factorial, what it means is I'll write 3. We're going to multiply it with 2. We are going to multiply it with 1. Now look at that. We have the same first term, which is 3. We have 3 minus 1, which is 2. We have 3 minus 2, which is 1. So that thing which you are just seeing here, all of it can just be a factorial of what? The same term, which is n plus k. So this whole thing can be written as n plus k factorial, because this shows a pattern of a factorial divided by n factorial, k factorial, x to the power what? To the power n. This is n equal to 0, infinite. Now, friends, the question is find the radius of convergence. Find the radius of convergence. The radius of convergence says as the limit of n approaches infinite of a sub n divided by n sub n plus 1. Now, what is a sub n? A sub n, it is the actual function we have. So a sub n is equals to n plus k factorial divided by n factorial plus k what? Factorial. Now, what is a sub n plus 1? A sub n plus 1, where there is n, we're just going to be adding n plus 1. Where there is n, we're just going to be putting n plus 1. So this is the same as n plus 1 plus k what? Factorial. On the bottom we have n plus 1 factorial multiplied by what? K factorial. So what is the radius of convergence saying? We're just going to divide this by this with the limit as n approaches what? N approaches infinity. So let's just go ahead and divide. So the ratio test, the radius of convergence is found using the reciprocal of the ratio test. So we're just going to say the limit as n approaches infinite of a sub n divided by a sub n plus 1. So this, I'm going to say the limit as n approaches infinite. Now what is a sub n? It is n plus k factorial divided by n factorial k factorial. Now look at the way I'm going to say. I'm not going to say divided by, I'm going to say multiplied. So when I multiply, we know that this was going to be division. There's division, so we're going to divide this. So we are going to change the sign to multiplication. When we change the sign to multiplication, you know that you are changing this. The bottom goes to the top comes to the bottom. So we are just swapping the denominator and the numerator. So for a sub n, we are swapping the numerator and the denominator. We are going to have n plus 1 factorial k factorial on top divided by n plus 1 plus k factorial. This is what we have. Now from what we have, we can see that this is n plus k factorial, but on the bottom we have n plus 1 plus k factorial. So we're going to use the laws of factorial. We know that, let's say for 3 factorial. 3 factorial, well, we can break it down to say this is 3 multiplied by 2 multiplied by 1. So what is 2 factorial? 2 factorial is the same as 2 multiplied by 1. So for this 3 factorial can be written as, you can see that this is 2 factorial. So 3 factorial is the same as 3 multiplied by what? 2 factorial. So this knowledge is the one that we are going to use on how to simplify this. So the limit as n approaches infinite of n plus k factorial, n plus k factorial, n plus k factorial multiplied by n plus 1 factorial multiplied by k factorial divided by n factorial k factorial. Then let's start with this. So for this we can say n plus 1 plus k. So I'll write n plus 1 plus k. Instead of adding a factorial, I'm going to say less 1. Instead of writing 3, we have said 3 minus 1. So this is what we have done. We are doing here. So this will be n plus k. Now, instead of finishing it up, we can see that from here, the next term, the next number that is going to follow 3 is what? It's a factorial. So this will be what? A factorial. This will be a factorial. Now we can see that this one and this one will cancel. Now the same thing is observed. The same thing is observed here. We have n plus 1 factorial. On the bottom we have just what? We have just n factorial. Let's go ahead and cancel it out as well. Let's go ahead and cancel it out. So we have n plus 1. Then minus 1, we are going to have n factorial. This is k factorial divided by n factorial, k factorial, n plus 1 plus k, like this. So this is what we have. So you can see that k factorial and k factorial, they will go. N factorial and n factorial will go. So what are we remaining with? We have the limit as n approaches what? Infinite, of n plus 1 divided by n plus 1 plus k. Now, ladies and gentlemen, here what we have, it is a simplified version of our question. So we are going to divide all the terms throughout with n. So this is going to be 1 plus 1 over n. This is going to be 1 plus 1 over n plus k over n. Now, as n approaches infinite, all the terms which have n, they are going to go to 0. So we are going to have just 1 divided by 1. So the radius of convergence is going to be 1. The radius of convergence is going to be 1. Friends, thank you for watching. Bye-bye.